Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
We have 4 stoichiometry problems we've been asked to perform. In each case, doing a synthesis reaction starting with 3.67 grams of a limiting reactant and then finding how much product can be produced in each case. So for the first one, we have the reaction barium reacting with chlorine gas yields barium chloride. And we're told that we are going to begin with 3.67 grams of barium. And we want to find the product. So we need to go to a mole ratio and we want to find mass in grams of the product. So we'll have to pass through our mole ratio and then get back to using molar mass. Now if you look at the periodic table, you'll see that barium has a molar mass of 137.3 grams for every mole. Now if you look at all the coefficients here, you'll see it's 1 to 1 to 1. So our mole ratio is going to be quite simple. It'll be a mole of barium for every mole of product. And then we'll have to use our molar mass. So for a mole of barium chloride, we'll have to add up. Barium has a molar mass of 137.3. Chlorine has a mass of 35.45, but we have 2 of them. So we'll add all that up, and it will come out to be 208.2 grams of barium chloride. Now if this was done correctly, all of the units should cancel except for mass of barium chloride. So let's check that it does. And it looks like it will. So we'll take our 3.67 times our 208.2 and divide by 137.3. And once this is done, it'll come out to be 5.57 grams of barium chloride. And we know this has to have 3 significant figures since we were given 3 to begin with, 3.67. On part B, we have a new reaction. It's calcium oxide reacts with carbon dioxide to form the ternary compound calcium carbonate. And once again, we're starting with our first reactant and assuming that the CO2 is excess. We'll begin again with 3.67 grams of calcium oxide. So we'll follow the exact same steps as before. We'll transfer to moles, do a mole ratio, and then get back to mass of our product. Now, the molar mass of calcium is 40.1 and the molar mass of oxygen is 16 grams per mole. So we'll add those together and get 56.1 grams of calcium oxide for every mole of this substance. Once again, we have a 1 to 1 to 1 ratio, so our mole ratio will be quite simple. For every mole of calcium oxide, there is a mole of calcium carbonate. And then we need mass of our product, so again we'll add this up. The calcium is 40.1, the carbon is 12, and the oxygen is 16, but there's 3 of them. So adding all that up, we'll get it to be 100.1 grams of calcium carbonate. Let's check our units again. Grams of calcium oxide cancel each other out, moles of calcium oxide cancel each other out, and moles of calcium carbonate cancel each other out. We are indeed left with only grams of calcium carbonate, which we wanted. So let's take 3.67 times 100.1, divide off 56.1, and again we'll need 3 significant figures. This will come out to be 6.55 grams of calcium carbonate. Let's look at part C. On part C, again we have a synthesis reaction, but this time we don't have a 1 to 1 mole ratio. We have 2 moles of magnesium react with a mole of oxygen to form 2 moles of magnesium oxide. Once again, we're assuming that our our reactant on the left is limiting and the other one is excess. So let's begin. we begin again with 3.67 grams of magnesium. Let's convert this to moles. According to the periodic table, there are 24.3 grams of magnesium in a mole of magnesium. Now this time we do have a coefficient, so in our mole ratio we'll have 2 moles of magnesium. But our product also has a coefficient of 2. So we can actually cancel these out, since 2 divided by 2 will be 1. And then let's convert our moles over to mass. Molar mass. Magnesium has a molar mass of 24.3 grams per mole. Oxygen has 16. Add it all together, you get 40.3. Let's check that our units are consistent. Grams of magnesium cancel. Moles of magnesium cancel. Moles of magnesium oxide cancel. We indeed are left with only wanting the unit of mass for our product. So we'll take 3.67, we'll multiply that 40.3, we'll divide it by 24.3, and we'll end up with 6.09 grams of magnesium oxide. And let's wrap up with part D. Part D, which says we have 4 moles of aluminum reacting with 3 moles of oxygen, forming 2 moles of aluminum oxide. Once again, limiting and excess. So let's begin. We're given again 3.67 grams of aluminum. For every mole of aluminum, according to the periodic table, there are 27 grams of aluminum. Follow this up by our coefficient is 4. So we'll put 4 moles of aluminum in our mole ratio. And then our product has 2 moles. 2 moles of aluminum oxide. So I can go ahead and simplify this, divide each of them by 2, and I get 1 and 2. And then we'll wrap up for every mole of aluminum oxide, what is the molar mass? Let's find out. Aluminum is 27 according to the periodic table, and there's 2 of them. Oxygen is 16, and there's 3 of them. Add it all together, and we'll get it to be 107 grams of aluminum oxide. So let's take 3.67, multiply it by 107, divide it by 27, and divide it by 2. And we'll get a final result of 6.93 grams of aluminum oxide. So you can see each of these problems is basically an identical type of problem. You're just given slightly different numbers based on the reaction.